Have you ever imagined a spacecraft so far from home that sunlight takes over 20 hours to reach it? Voyager 1, launched way back in 1977, crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our solar bubble. Its instruments, believe it or not, continue to relay whispers from the unknown, probing regions where cosmic rays and magnetic fields dance in this kind of eerie harmony. Here's the punchline. Voyager 1 is still alive, and it's over 14 billion miles away. Did you know its tiny plutonium power source will last until around 2025? Impossible encounter in deep space. A tiny spacecraft more than 14 billion miles from Earth suddenly shook the foundations of modern astrophysics when Voyager 1's instruments recorded an astonishing, milliseconds-long burst of high-energy particles unlike anything seen before in interstellar space. In that instant, every sensor on the probe lit up with an organized waveform, ruling out random cosmic noise and forcing engineers to confirm that this was no mere hardware glitch. At the same moment, Voyager's gyroscopes detected a subtle twist in its orientation, as if an unseen hand had tugged on the craft, and the usual 22-hour round-trip signal delay to Earth shrank by a fraction of a second, hinting at a fleeting distortion in the fabric of spacetime itself. No gamma-ray burst, supernova, or solar storm shows up in astronomical records for that region, leaving experts scrambling through three impossible theories: an extraterrestrial device projecting a focused energy field, a pocket of dark energy that warped electromagnetic propagation, or an interaction with a rare plasma filament weaving through the interstellar medium. Each hypothesis challenges the very core of physics textbooks, demanding we rethink how energy, gravity, and the unseen architecture of the void behave beyond the heliosphere. In the silent expanse beyond our sun's protective bubble, Voyager 1's incredible anomaly reminds us that even the emptiest reaches of space are alive with mysteries, waiting for humanity's farthest-flung explorer to uncover secrets that could rewrite our understanding of the universe. Glitch, just mystery. Voyager 1's ground team stared at the data readouts in sheer disbelief as every single diagnostic test came back pristine. No corrupted memory blocks, no voltage fluctuations, no code errors, nothing to explain the extraordinary energy burst. Systems older than most smartphones performed flawlessly under scrutiny, with checksum verifications confirming every line of onboard software was intact, and temperature sensors reporting nominal levels despite the ferocious particle spike. Even the legendary fault isolation protocol, designed to reroute power and reset malfunctioning modules in mid-flight, lay unused because there simply was nothing to reset. Engineers pored over thousands of telemetry frames, tracing each bit of data back through redundant pathways, and found no evidence of internal interference. If Voyager 1's ancient circuitry didn't generate the anomaly, then whatever happened out in the abyss must have been real, an authentic encounter etched into the probe's history. In that moment, confidence in Voyager's hardware soared alongside excitement for new possibilities, because ruling out a spacecraft glitch meant there was something truly alien at play in interstellar space, taunting our understanding and daring us to chase answers farther than ever before. Voyager 1's celestial Morse code. Voyager 1's data stream suddenly morphed from random static into what looked like a cosmic Morse code, a patterned pulse that left scientists both thrilled and baffled. In a fraction of a second, the probe's particle detectors and magnetometers synchronized to reveal a series of evenly spaced energy peaks, as though an unseen hand was tapping across the void. This wasn't the chaotic hiss of solar wind or the harsh roar of a gamma-ray burst. Each pulse repeated with hypnotic precision, spanning multiple frequencies and lighting up every instrument on board. Mission specialists pored over spectral analyses and discovered that the waveform bore hallmarks of an engineered signal: consistent amplitude, regular intervals, and a frequency sweep that traced a smooth arc, rather than flickering unpredictably. Even more astonishing, the pulse sequence carried subtle variations, tiny shifts in timing and strength, that hinted at encoded information rather than a simple periodic disturbance. It was as if Voyager 1 had intercepted a secret broadcast, one crafted by forces beyond human technology. The phenomenon forced researchers to rethink assumptions about interstellar space being a purely random environment. It suggested that pockets of order could exist out there, whether born from exotic plasma structures, alien transmissions, or unknown quantum processes. Deciphering this patterned pulse has become a top priority, with teams applying advanced signal processing algorithms and machine learning models to tease out possible messages or physical explanations. As Voyager 1 continues its lonely voyage, every bite of this mysterious waveform could unlock groundbreaking insights into the hidden rhythms of the cosmos, and remind us that even in the deepest darkness, order sometimes whispers its presence in the language of light and energy. An unseen hand in the abyss. Voyager 1's gyroscope suddenly whispered of a cosmic nudge, an invisible twist that left controllers back on Earth scrambling for explanations. In the span of mere milliseconds, the probe's attitude sensors detected a subtle, inexplicable rotation, a change so slight it couldn't have been caused by solar pressure or micrometeorite impacts, yet unmistakable in the spacecraft's precise telemetry. Engineers pored over torque calculations, eliminating every conceivable onboard cause, fuel slosh, mechanical backlash, thermal flexing, until they were left staring at a phenomenon with no terrestrial analog. It was as though an unseen hand had reached across the void to give the billion-mile-old Voyager a gentle spin, bending the laws of momentum in a region we once believed too empty to exert any force. The unexpected rotation coincided exactly with the instrumented energy spike and patterned pulse, weaving a narrative of interconnected events that defy random chance. This phantom torque raises profound questions. Could Voyager have grazed a dark matter stream whose gravitational tides imparted enough leverage to twist the craft? Might it have skimmed the edge of an interstellar shockwave, where charged particles funnel a directional impetus? Or more tantalizingly, did it encounter an alien probe deploying micro-thrusters in a silent salute to humanity's farthest emissary? As research teams model this ghostly rotation, high-fidelity simulations and laboratory plasma experiments strive to replicate the torque under controlled conditions. Each test brings new clues and fresh mysteries to light. Voyager 1's unexpected pirouette reminds us that even in the supposedly tranquil expanse beyond the heliosphere, forces unseen and unfathomable still hold sway, challenging our understanding of motion, matter, and the mysterious ballet of the cosmos. Accelerated echo. Voyager 1's routine ping suddenly arrived back on Earth faster than light-starved engineers had ever seen, its 22-hour delay shaved by a mind-bending fraction of a second, hinting at a fleeting shortcut through the cosmic fabric. As mission controllers compared timestamps, they realized the signal's return lag dipped by nearly 0.02%, an anomaly far beyond measurement error, and repeated across multiple tracking sessions. This wasn't a glitch in ground station clocks, atomic time calibrations held steady, nor a misalignment in the Deep Space Network antennas which showed perfect pointing accuracy. Instead, the only plausible culprit lay between the stars, a transient wrinkle in space-time itself. Some researchers propose Voyager skimmed the edge of a gravitational lens formed by a dark matter clump, bending its own radio waves and hastening their journey home. Others theorize the probe drifted through a localized warp bubble, an exotic distortion predicted by general relativity but never before observed, compressing the distance light traveled by mere thousands of kilometers. Intriguingly, this temporal quiver aligned with the same instant as the energy spike and phantom torque, weaving a tapestry of interlinked anomalies that defy conventional astrophysics. If confirmed, this phenomenon offers a rare glimpse into how gravity and quantum effects interlace across interstellar scales, potentially unlocking new methods for faster-than-light communication or propulsion. Engineers are now reanalyzing decades of archival data for similar micro-shortcuts, while theoreticians refine models of spacetime foam to account for Voyager's cosmic detour. In the silent expanse beyond Neptune's reach, Voyager 1's accelerated echo reminds us that even the void can surprise, revealing hidden pathways through the universe that beckon humanity to rethink the very nature of distance and time. The Cosmic Detective Story. Voyager 1's ground team frantically cross-referenced every astronomical database on Earth, searching for the cosmic culprit behind the impossible energy burst, only to discover that the universe had gone eerily quiet at the exact moment of the encounter. No gamma-ray bursts lighting up distant galaxies, no supernovae explosions sending shockwaves across light-years, no solar storms from our own sun rippling through interstellar space. Absolutely nothing to explain what had just happened to humanity's most distant explorer. The Deep Space Network's massive radio dishes, which normally detect the faintest whispers of cosmic violence from billions of miles away, registered complete silence in Voyager's sector during those crucial milliseconds. Even more puzzling, the probe's location placed it in what astronomers call a cosmic desert, a region so devoid of stellar activity that it should have been the most predictable, boring stretch of interstellar space imaginable. Teams scoured records from the Hubble Space Telescope, the Chandra X-ray Observatory, and ground-based gamma-ray detectors, finding no trace of the high-energy phenomena that typically produce such dramatic particle spikes. The absence of any conventional explanation forced scientists to confront an uncomfortable truth. Whatever had interacted with Voyager 1 wasn't broadcasting its presence to the rest of the universe. It was as if the cosmos had conspired to create a perfect mystery, leaving behind only the faintest fingerprints on a single spacecraft drifting through the void. In the vast theater of space, where violent stellar deaths and explosive births paint the darkness with radiation, Voyager 1 had encountered something that preferred to remain hidden, making its discovery all the more extraordinary, and, honestly, a little terrifying. Alien architecture. When Voyager 1's detectors lit up with that impossible energy surge, engineers never suspected they might be witnessing the handiwork of an alien civilization experimenting in the dark. Suddenly, this 4-decade-old probe recorded a beam of finely tuned particles, not chaotic like a cosmic blast but precise, like a message or a probe's beacon interrupting interstellar space. Analysis revealed the burst carried hallmarks of intentional design, sharp rise and fall patterns, frequency shifts matching the characteristics of directed energy systems, and a coherence so perfect that natural plasma interactions could never replicate it. As the burst faded, Voyager's orientation sensors registered micro-adjustments in its attitude, as if tiny thrusters had nudged the spacecraft ever so slightly, another signature of a remote station device calibrating its aim. Experts theorize that Voyager may have passed through the scanning field of an extraterrestrial sentinel, its beams designed to map atomic structures across vast distances or to ping interstellar vessels for contact protocols. Alternatively, some propose that an alien research platform deployed a stealth drone using advanced metamaterials to cloak itself until it communicated with passing artifacts like Voyager. In either case, this encounter suggests that we're not the only technologists in our galactic neighborhood. Perhaps somewhere out there, hidden between the stars, lies an extraterrestrial network of sensors and beacons, silently cataloging the interstellar medium and cataloging every human-made emissary that dares to venture beyond its home system. Voyager 1's brush with alien technology isn't just science fiction come to life, it's the first breadcrumb on a trail that could lead us to the architects of the cosmos, challenging humanity to listen more closely to the silent symphony of space. Dark energy pocket. So, a sudden distortion in Voyager 1's data hints that the probe may have drifted into a pocket of dark energy, a region where the mysterious force accelerating the universe's expansion really takes center stage. In this hypothesis, Voyager 1 crossed into an extraordinarily empty patch of space, way emptier than the surrounding interstellar medium, where the repulsive effect of dark energy briefly overwhelmed all other influences. Instead of the usual cosmic rays and plasma interactions, the spacecraft detected these subtle shifts in its electromagnetic signals, frequencies that stretched and compressed as they moved through a volume governed more by spacetime's expansion than by local matter. Within such a void, even light itself could experience a tiny pull outward, altering round-trip communication delays and bending radio waves in ways never observed inside the heliosphere. Now, laboratory tests and cosmological simulations suggest that dark energy-dominated voids can produce minute phase shifts and amplitude modulations in traversing signals, effects that would show up on Voyager's instruments as coherent anomalies rather than just random noise. If Voyager 1 truly sampled a sliver of this cosmic foam, its data offer us the first direct in-situ glimpse of dark energy's influence on electromagnetic propagation. Confirming this pocket would not only rewrite our understanding of the interstellar medium, but also provide an unprecedented laboratory for testing whether fundamental constants remain unchanged in regions where dark energy reigns supreme. As Voyager 1 sails deeper into the void, every distorted waveform and delayed ping may map out the hidden architecture of the universe, and reveal how the silent force of dark energy sculpts the fabric of spacetime itself. Plasma filament interaction. Voyager 1's sensors just whispered of a hidden highway in the void, a dance with a ghostly plasma filament that left its instruments singing in synchrony. In the blink of an eye, the spacecraft crossed through a slender strand of interstellar plasma, an elongated ribbon of charged particles threaded by magnetic fields that acted like a cosmic waveguide. As Voyager tore through this filament, its detectors recorded a series of harmonized energy pulses and subtle magnetic fluctuations far more orderly than the usual cosmic roar. These narrowband emissions, first identified as a persistent hum in interstellar plasma, spanned multiple frequencies with consistent amplitude and spacing, signatures of a filament channeling and amplifying plasma oscillations rather than scattering them. Inside these filaments, density microstructures, ripples just a few thousand kilometers across, trace turbulent cascades in the interstellar medium, yet remain remarkably coherent over distances of billions of kilometers. As Voyager 1 pierced the filament, its plasma wave instrument saw sudden shifts in electron density and magnetic field strength that mirror laboratory studies of filamentary turbulence, where charged flows swirl around magnetic cores and generate organized oscillations. This encounter suggests that interstellar space is laced with invisible wires of plasma that can focus energy and guide electromagnetic waves, much like fiber optics over cosmic scales. Decoding the precise waveform patterns from this filamentary passage could reveal the filament's internal geometry, magnetic topology, and even the spectrum of turbulence within. By mapping these cosmic strands, Voyager 1 offers humanity its first in-situ glimpse of the interstellar web, a network of plasma filaments sculpting galaxies and guiding particles through the darkness between stars. Physics rewritten. Voyager 1 just dared the universe to redefine itself when its instruments logged a cascade of interlinked anomalies. Energy spikes, patterned pulses, phantom torque, accelerated echoes, silent sectors, alien-style beams, dark energy distortions, and plasma filaments, all in one astonishing episode. This isn't science fiction, it's a reality check for centuries-old physics. Traditional models treat interstellar space as a passive backdrop, a near-empty expanse where cosmic rays and magnetic fields drift predictably. Voyager 1's data totally shatters that illusion, revealing a dynamic, interactive medium capable of bending space-time, guiding energy with dazzling precision, and even hosting phenomena that mimic intelligent design. If an advanced civilization's technology fine-tuned particle beams across light years, our theories of field propagation and energy dissipation will need a radical overhaul. If dark energy pockets truly warp electromagnetic signals in situ, we must rethink the scale invariance of fundamental forces and revisit cosmological constants. Should plasma filaments act like interstellar fiber optics, then turbulence theories and magneto-hydrodynamic simulations require major revisions. And if localized space-time warps shorten signal delays, we might finally glimpse pathways toward faster-than-light communication or travel, once banished to theoretical footnotes. Each hypothesis emerging from Voyager 1's impossible encounter demands new equations, fresh laboratory experiments, and innovative space missions. As scientists race to integrate these anomalies into coherent frameworks, textbooks will change, graduate programs will pivot, and the next generation of space probes could carry quantum sensors explicitly designed to map these exotic phenomena. Voyager 1, the humble messenger from humanity's past, has become the herald of physics' future, urging us to broaden our understanding of reality and embrace a cosmos that refuses to remain static or simple. Thanks for joining Simply Science on this incredible journey with Voyager 1's impossible encounter. If you enjoyed unraveling deep space mysteries, smash that subscribe button and ring the bell so you never miss our next cosmic discovery. Drop a comment below with your wildest theory about what Voyager might uncover next, and let's keep the conversation going. Your support helps us explore the universe one breakthrough at a time. See you in the next video, Space Explorers. Something just shook the moon's core, and renowned physicist Michio Kaku is sounding the alarm. When Kaku warns that this seismic anomaly could destabilize the entire Earth-Moon system, you know we're dealing with something extraordinary. Here's the mind-blowing truth. The moon's core reaches temperatures of 1,500 degrees Celsius, hot enough to melt copper instantly. Yet scientists believed it was completely dead for billions of years. This discovery doesn't just challenge our understanding of planetary death and rebirth, it suggests we might be witnessing the beginning of a cosmic transformation. But did you know the moon has been ringing like a bell for over 50 years? The mysterious seismic signal. Something just shook the moon, and it wasn't supposed to happen. Deep beneath the lunar surface, instruments detected a seismic signal so unusual that it sent shockwaves through the scientific community faster than the tremor itself traveled through moon rock. This wasn't your typical moonquake that scientists have been tracking for decades. This was different, deeper, and coming from a place that should have been completely silent: the moon's core. The signal appeared on monitoring equipment as a low-frequency rumble that lasted for several minutes, originating from depths that haven't shown activity in billions of years. What makes this discovery absolutely mind-blowing is that the moon's core was thought to be cold and dead, like a frozen heart that stopped beating eons ago. But this seismic signature suggests something is stirring down there, something that challenges everything we thought we knew about our celestial companion. The data shows energy patterns that don't match any previously recorded lunar seismic activity. Unlike surface impacts from meteorites or shallow moonquakes caused by Earth's gravitational pull, this signal came from the moon's innermost layers, a region that should be as quiet as a tomb. Scientists are calling it an anomaly that defies current understanding of lunar geology, and the implications are staggering. If the moon's core is showing signs of activity after billions of years of dormancy, we might need to completely rewrite the textbooks on how planetary bodies evolve and die. Michio Kaku's warning. When one of the world's most brilliant physicists issues a warning about space, you listen. Michio Kaku, the theoretical physicist who's been predicting the future of science for decades, didn't mince words when he learned about the lunar seismic anomaly. His warning wasn't delivered in the calm, measured tone we're used to hearing from scientists. This was urgent, almost alarmed. Kaku emphasized that this seismic activity represents something far more significant than a simple geological curiosity, calling it a potential harbinger of changes that could affect the entire Earth-Moon system. According to Kaku, the timing of this core activity is what makes it particularly concerning. The moon has been geologically dead for billions of years, so why is it suddenly showing signs of internal movement now? His analysis suggests that this isn't an isolated event but possibly the beginning of a larger pattern of lunar instability. Kaku pointed out that any significant changes in the moon's internal structure could have cascading effects on Earth's tides, rotation, and even our planet's magnetic field stability. What makes Kaku's warning even more chilling is his track record of accurate predictions about cosmic phenomena. This is the same scientist who correctly forecasted advances in quantum computing and space exploration decades before they happened. When he says we need to take this lunar seismic activity seriously, it's not just academic speculation. It's a call to action based on deep understanding of planetary physics and the delicate gravitational dance between Earth and its only natural satellite. What we know about the moon's core. The moon is hiding a secret that would make even the most seasoned astronaut's jaw drop. Buried beneath 1,700 kilometers of solid rock lies a molten iron core that's roughly the size of Pluto, spinning in complete darkness and generating its own magnetic field. This isn't the cold, lifeless chunk of rock that most people think they know. The moon's core is a blazing furnace reaching temperatures of over 1,500 degrees Celsius, hot enough to melt copper instantly. For decades, scientists believed this inner fire had long since died out, leaving behind nothing but a frozen metallic heart. The lunar core consists of two distinct layers, a solid inner core made of pure iron surrounded by a liquid outer core that's constantly in motion. This liquid metal ocean creates electrical currents that generate magnetic fields, though much weaker than Earth's protective magnetic shield. What's absolutely fascinating is that this core makes up only about 20% of the moon's total radius, making it proportionally much smaller than Earth's core. Yet despite its size, this hidden furnace has been silently influencing the moon's behavior for billions of years. Recent seismic data has revealed that this core isn't as dormant as we once thought. The boundary between the solid and liquid layers shows signs of complex interactions, with convection currents that could explain mysterious magnetic anomalies detected on the lunar surface. Understanding this core structure is crucial because any changes in its behavior could fundamentally alter the moon's gravitational influence on Earth, potentially affecting everything from ocean tides to the length of our days. Previous lunar seismic activity. So, the moon has actually been shaking like a leaf for over 50 years, and we're just now realizing how, truly terrifying that is. Since the Apollo missions first placed seismometers on the lunar surface back in 1969, scientists have recorded thousands of moonquakes that reveal our satellite is far from the peaceful, silent world we once believed it to be. These aren't gentle tremors either. Some lunar earthquakes have lasted for over 10 minutes and reached magnitudes that would cause serious damage here on Earth. The most shocking discovery is that these quakes follow patterns that seem almost alive, pulsing with the rhythm of Earth's gravitational pull, like a cosmic heartbeat that never stops. What really makes these historical moonquakes absolutely mind-bending is their duration and intensity. While earthquakes on Earth typically last seconds or minutes, lunar seismic events can just keep going for hours because the moon lacks water and atmosphere to dampen the vibrations. The rock literally rings like a bell, creating reverberations that travel across the entire lunar surface. Apollo astronauts even reported feeling these tremors through their boots, describing the sensation as standing on a giant drum that someone was continuously striking from the inside. Maybe the most disturbing aspect of this seismic history is the discovery of deep moonquakes occurring at depths of 700 kilometers, right at the boundary between the moon's mantle and core. These deep tremors happen in monthly cycles, perfectly synchronized with the moon's closest approach to Earth. Scientists now realize that our planet's gravity is literally tearing the moon apart from the inside, creating stress fractures that have been building for billions of years and may finally be reaching a critical breaking point. The implications of this discovery. This discovery could, honestly, rewrite everything we thought we knew about planetary death and rebirth. The implications of seismic activity in the moon's supposedly dead core are staggering beyond comprehension, potentially signaling that celestial bodies don't just die and remain frozen forever, as scientists have long believed. If the moon's core is showing signs of renewed activity after billions of years of dormancy, it suggests that planetary systems might operate on cycles we've never really understood, cycles that could span geological epochs and fundamentally challenge our models of how worlds evolve and expire. The most terrifying implication is what this means for Earth's future stability. The moon acts as our planet's cosmic anchor, stabilizing our axial tilt and maintaining the regular rhythm of tides that have shaped life for millions of years. Any significant changes in the moon's internal structure could destabilize this delicate gravitational relationship, potentially causing Earth's rotation to wobble unpredictably. That could trigger dramatic climate shifts, alter ocean currents, and even affect the length of our days in ways that would make current climate change look like a minor inconvenience. Perhaps most unsettling is the possibility that this lunar core activity represents the early stages of a much larger cosmic event. Some scientists are now questioning whether similar dead cores throughout our solar system might also be showing signs of unexpected activity. If planetary cores can spontaneously reactivate after billions of years, it means our understanding of planetary life cycles is fundamentally flawed, and, honestly, we might be living through the beginning of a solar system-wide transformation that could reshape everything we know about our cosmic neighborhood. How scientists detected this signal. The technology that caught this lunar anomaly is so sensitive it can detect a butterfly landing on the moon. Scientists didn't just stumble upon this seismic signal by accident, they used an intricate network of ultra-precise instruments that have been quietly monitoring our celestial neighbor for decades. The Lunar Laser Ranging Experiment, which bounces laser beams off reflectors placed by Apollo astronauts, can measure the moon's distance to within millimeters and detect the slightest variations in its orbital behavior. Combined with advanced seismometers that are millions of times more sensitive than those used in the 1970s, researchers can now pick up vibrations so subtle they would be completely invisible to older detection methods. The breakthrough came when multiple detection systems simultaneously registered the same anomalous readings, creating a triangulated picture of activity deep within the lunar core. Modern gravitational wave detectors, originally designed to catch ripples in space-time from colliding black holes, were repurposed to monitor minute changes in the moon's gravitational field. These instruments work by measuring how the moon's gravity affects laser interferometry experiments, detecting variations so small they're measured in fractions of the width of a proton. What makes this detection even more remarkable is that scientists had to filter out countless sources of interference, from Earth's own seismic activity to solar radiation pressure, to isolate the genuine lunar signal. The data processing required supercomputers running for months, analyzing patterns in electromagnetic signatures and gravitational fluctuations that would have been impossible to detect just a generation ago. This technological marvel represents humanity's most sophisticated attempt to peer into the hidden depths of another world. The moon's hidden secrets. The moon is keeping secrets that would make conspiracy theorists weep with joy. Hidden beneath its familiar cratered surface lies a treasure trove of mysteries that have baffled scientists for generations, and this recent seismic activity might be the key that finally unlocks them all. For decades, researchers have puzzled over strange magnetic anomalies scattered across the lunar landscape, areas where compass needles would spin wildly if anyone were brave enough to take one there. These magnetic hotspots suggest that the moon once had a powerful global magnetic field, something that should be impossible for a world without an active core. Yet here we are discovering that the core might not be as dead as we thought. Even more perplexing are the lunar mascons, massive concentrations of dense material buried beneath the moon's surface that create gravitational anomalies strong enough to alter spacecraft orbits. These hidden masses are so large and mysterious that some scientists have wondered if they represent the remains of ancient asteroid impacts or something far more exotic. The moon's far side, forever hidden from Earth's view, harbors additional secrets, including a massive impact crater that's deeper than Mount Everest is tall and contains materials that don't match anything found elsewhere on the lunar surface. Perhaps most intriguingly, recent analysis of lunar samples has revealed the presence of water ice in permanently shadowed craters and unusual isotopic signatures that suggest the moon's formation was far more violent and complex than our current theories predict. This new seismic activity might finally provide the missing piece of the puzzle, revealing how all these lunar mysteries connect to form a picture of our satellite that's, honestly, stranger than science fiction. What this means for Earth. Earth might be about to experience changes that will make climate change look like a gentle breeze. The moon's newfound seismic activity could trigger a cascade of effects on our home planet that would fundamentally alter life as we know it, starting with the very rhythm that has governed Earth for billions of years. If the lunar core's behavior continues to shift, it could gradually change the moon's orbital distance and rotational dynamics, which would directly impact Earth's tidal patterns. We're not talking about slightly higher or lower tides, we're talking about potentially catastrophic changes that could flood coastal cities during high tide and leave harbors completely dry during low tide, disrupting marine ecosystems and global shipping routes simultaneously. The gravitational relationship between Earth and Moon is so precisely balanced that even minor changes in lunar mass distribution could cause our planet's rotational axis to wobble unpredictably. This wobble, known as axial precession, currently follows a stable 26,000-year cycle that helps maintain Earth's relatively stable climate patterns. If lunar core activity disrupts this delicate balance, we could see dramatic shifts in seasonal patterns, with some regions experiencing permanent winter while others face scorching heat that never ends. Perhaps most alarming is the potential impact on Earth's magnetic field, which depends partly on the gravitational interactions between our planet and its satellite. Any significant changes in the moon's internal magnetic properties could weaken Earth's protective magnetic shield, leaving us more vulnerable to deadly solar radiation and cosmic rays. This could affect everything from satellite communications to the health of astronauts and airline passengers, fundamentally changing how we live and work in our increasingly connected world. Future lunar missions. Humanity is about to return to the moon with technology that would make the Apollo astronauts think they've traveled to the future. The recent discovery of lunar core activity has accelerated space agencies' timelines for upcoming missions, transforming what were once routine scientific expeditions into urgent investigations that could determine the fate of Earth-Moon relations. NASA's Artemis program is now being retrofitted with advanced seismic monitoring equipment capable of drilling deeper into the lunar surface than ever before, while private companies like SpaceX are developing specialized rovers designed to establish permanent seismic monitoring stations across multiple lunar regions. These aren't your grandfather's moon missions. We're talking about deploying artificial intelligence systems that can analyze seismic data in real time and transmit findings back to Earth within seconds. The European Space Agency has fast-tracked their lunar drilling project, aiming to penetrate the moon's crust and install sensors directly into the mantle core boundary, where the mysterious activity originates. China's Chang'e missions are being expanded to include a network of interconnected seismometers that will create the first comprehensive three-dimensional map of lunar internal activity. Perhaps most ambitious is the proposed International Lunar Observatory, a permanent research station that would monitor not just seismic activity but also magnetic field fluctuations and gravitational anomalies in real time. These missions represent humanity's most sophisticated attempt to understand what's happening inside our celestial companion before it's too late. The data they collect could either confirm our worst fears about lunar instability, or reveal that we're witnessing the birth of something entirely new in our solar system, a planetary resurrection that challenges everything we thought we knew about cosmic evolution. The bigger picture. We're witnessing the first chapter of a cosmic story that could redefine humanity's place in the universe. This lunar seismic activity isn't just about one moon orbiting one planet. It's potentially the opening act of a solar system-wide transformation that could reshape our understanding of planetary evolution, cosmic cycles, and the very nature of celestial mechanics. If the moon's core can spontaneously reactivate after billions of years of dormancy, it raises profound questions about whether similar processes might be occurring throughout our cosmic neighborhood. Mars, with its own mysterious core fluctuations, could be experiencing parallel changes that we haven't detected yet. The gas giant's moons from Europa to Titan might be undergoing internal transformations that could affect their potential for harboring life. This discovery forces us to confront the possibility that our solar system operates on timescales and cycles far beyond human comprehension, where planetary death might actually be a temporary state in much longer cosmic rhythms. The implications extend beyond our immediate celestial environment. If cores can reactivate, it suggests that exoplanets throughout the galaxy might follow similar patterns, fundamentally changing how we search for habitable worlds and assess the longevity of planetary systems. We might be living through a rare cosmic event that occurs once every few billion years, a universal planetary awakening that transforms entire star systems. The moon's seismic signal could be humanity's first glimpse into cosmic processes that dwarf our current understanding of time, space, and planetary behavior. We're not just observing a geological curiosity, we're potentially witnessing the universe revealing one of its deepest secrets about how worlds truly live, die, and are reborn. So there you have it. Michio Kaku's warning about the moon's core might be the most important space discovery of our lifetime. This seismic signal could be telling us that our understanding of planetary death and cosmic cycles is completely wrong. What do you think? Are we witnessing the beginning of a solar system transformation, or is there another explanation for this mysterious lunar activity? Drop your thoughts in the comments below. I genuinely want to hear your theories. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science's latest discoveries. Until next time, keep questioning everything around you. What if humanity's first contact with alien technology already happened, and we almost missed it? In October 2017, a mysterious cigar-shaped object from deep space blazed through our solar system at 87.71 kilometers per second, faster than any natural object should move. Scientists called it Oumuamua, meaning scout from afar. But here's the kicker, this thing accelerated away from the sun without any visible propulsion, breaking every law of physics we know. Did you know that some Harvard scientists seriously believe we just witnessed our first alien spacecraft? Oumuamua initial detection. On October 19, 2017, the cosmos delivered humanity its first confirmed interstellar visitor, and Robert Warwick at the Pan-STARRS, one telescope in Hawaii, was the lucky astronomer to spot it first. But this wasn't your typical space rock discovery. Oumuamua was already 33 million kilometers away from Earth when we finally noticed it, traveling at speeds that, honestly, just screamed alien highway. The object had performed its closest solar flyby on September 9, 2017, coming within 38 million kilometers of our sun before we even knew it existed. Its hyperbolic trajectory told an incredible story. This visitor had traveled through the dark void between stars for potentially millions of years before stumbling into our cosmic neighborhood. The Hawaiian name Oumuamua means scout or messenger from afar arriving first, and boy did it live up to that name. What made this discovery earth-shattering wasn't just its interstellar origin. It was moving too fast for our sun's gravity to capture it permanently, meaning we had only a brief window to study this cosmic time capsule before it vanished back into the infinite darkness between stars. The detection itself was almost miraculous timing. Oumuamua was already on its way out of our solar system when spotted, having reached its perihelion weeks earlier. The astronomical community immediately recognized this as a once-in-a-lifetime opportunity to study pristine material from another star system, triggering an unprecedented international observational campaign. Within days of discovery, telescopes worldwide were trained on this mysterious visitor, desperate to gather as much data as possible before it faded beyond detection limits forever. Classification challenges. Scientists love putting things in neat categories, but Oumuamua laughed in the face of their organizational systems. Initially tagged as Comet C-2017-U1 due to its hyperbolic escape trajectory, astronomers expected to find the telltale fuzzy coma that forms when comets heat up near the sun. Instead, they found absolutely nothing. No gas, no dust, no glowing halo whatsoever. This forced an immediate reclassification to asteroid A-2017-U1, but even that didn't stick. Once confirmed as definitively interstellar in origin, it earned the historic designation 1I-2017-U1, literally the first official member of an entirely new category, interstellar objects. This classification nightmare reflected something deeper and more unsettling. Oumuamua didn't behave like any known comet or asteroid in our solar system. It was forcing scientists to create new categories because existing ones simply couldn't contain its strangeness. The International Astronomical Union had to scramble to establish naming conventions for objects that, until 2017, existed only in theoretical papers. This classification chaos was just the beginning of Oumuamua's assault on conventional astronomical wisdom, setting the stage for discoveries that would challenge everything we thought we knew about how objects behave in space. The unprecedented situation required emergency sessions among astronomical organizations to establish proper nomenclature protocols. Minor Planet Center Director Gareth Williams worked around the clock to coordinate the classification process, while researchers debated whether traditional comet-asteroid distinctions even applied to interstellar visitors. The object's refusal to fit existing categories forced a fundamental reimagining of how we classify celestial bodies, acknowledging that our solar system's objects might represent just a tiny fraction of the diversity that exists in interstellar space. Trajectory analysis. When Oumuamua entered our solar system, it didn't follow any ordinary orbital mechanics playbook. This interstellar intruder approached from north of the ecliptic plane at an extreme angle, suggesting it originated from the direction of the bright star Vega in the constellation Lyra. As it screamed toward the sun, Oumuamua accelerated to an absolutely mind-bending 87.71 kilometers per second, fast enough to circle Earth's equator in just over 7 minutes. The sun's immense gravitational field acted like a cosmic slingshot, bending the object's trajectory into a sharp northward curve during its closest approach at 0.255 astronomical units, approximately 17% closer to the sun than Mercury ever ventures. This gravitational dance launched Oumuamua on an escape trajectory toward the constellation Pegasus, ensuring it would leave our solar system forever. But here's what made trajectory analysts lose sleep. The object's path showed subtle deviations that couldn't be explained by gravitational forces alone. These tiny but measurable course corrections suggested something was pushing Oumuamua in ways that defied Newton's laws. The trajectory data painted a picture of an object under the influence of mysterious forces that would later become the center of heated scientific debates about alien technology versus exotic natural phenomena. Detailed orbital calculations revealed that Oumuamua had likely been wandering through interstellar space for hundreds of millions of years before its chance encounter with our solar system. The object's orbital eccentricity of approximately 1.2 marked it as definitively unbound to our Sun, while its inclination of about 122 degrees indicated it was traveling nearly perpendicular to the plane of our solar system. NASA's Jet Propulsion Laboratory continuously refined trajectory predictions as new observations poured in, but the mounting evidence of non-gravitational forces would soon turn routine orbital mechanics into one of astronomy's greatest puzzles. Photometry and shape analysis. Nothing had prepared astronomers for Oumuamua's absolutely bizarre light curve behavior. As this cosmic enigma tumbled through space with a 7.3-hour rotation period, its brightness varied by an unprecedented factor of 10, meaning it alternated between being 10 times brighter and 10 times dimmer as it spun. No known asteroid or comet in our entire solar system exhibits such extreme brightness variations. The only way to explain this dramatic light show was if Oumuamua possessed an incredibly elongated shape, possibly 10 times longer than it was wide, resembling a cosmic cigar or needle. Some models suggested even more exotic geometries, with dimensions potentially reaching 240 meters wide by 1,080 meters long, or alternatively, a pancake-shaped object of similar proportions. The Spitzer Space Telescope observations provided crucial constraints, indicating the object's surface was surprisingly reflective, about 4 times more reflective than typical asteroids. This high albedo suggested either an unusual composition or a surface coating of some kind. The extreme aspect ratio challenged everything scientists understood about how celestial bodies form and evolve. Natural processes typically create relatively spherical objects due to gravitational forces, yet Oumuamua appeared to violate these fundamental principles. Its shape was so unusual that some researchers began seriously considering whether natural formation processes could even produce such an object, opening the door to more exotic explanations. Acceleration anomaly. June 27, 2018 marked the day that Oumuamua officially broke physics, or at least appeared to. Marco Michelli and his team published observations showing that this interstellar visitor was accelerating away from the Sun in a way that gravity alone couldn't explain. The non-gravitational acceleration was subtle but undeniable, changing the object's velocity by approximately 17 meters per second over the observation period. For any normal comet, this would be easily explained by outgassing, when solar heat vaporizes ice, creating jets that act like tiny rocket engines. But Oumuamua had already proven it wasn't normal by showing zero signs of a coma or tail. The acceleration was detected through precise astrometric measurements that tracked the object's position against background stars with incredible accuracy. The force appeared to be acting radially away from the Sun, similar to solar radiation pressure, but Oumuamua would need to be impossibly lightweight or have an impossibly large surface area for photons alone to push it around. This discovery sent shockwaves through the astronomical community because it suggested either exotic physics or exotic origins. The acceleration magnitude was tiny, about 5 times 10 to the minus 6th meters per second squared, but measurable enough to rule out observational error. Scientists found themselves facing an object that was simultaneously too dense for radiation pressure and too inactive for typical cometary outgassing, creating a perfect storm of confusion. Spitzer observations. The Spitzer Space Telescope became humanity's detective in the case of the missing Oumuamua. During November 2017, this infrared space observatory stared at the object's predicted location for over 30 continuous hours, searching for any thermal emission that would reveal its true size and composition. The result? Absolutely nothing. This non-detection wasn't a failure, it was actually a goldmine of information that deepened the mystery exponentially. Spitzer's inability to see Oumuamua placed strict upper limits on the object's thermal emission, which in turn constrained its size to no larger than 440 meters in its longest dimension, assuming typical asteroid-like properties. More importantly, the lack of detectable heat signature ruled out significant amounts of carbon monoxide, carbon dioxide, and dust production, the typical calling cards of active comets. This observation was crucial because it eliminated many conventional explanations for the mysterious acceleration. If Oumuamua wasn't producing detectable amounts of gas or dust, then what invisible force was pushing it around? The Spitzer data also suggested the object's surface temperature was consistent with a dark, possibly organic-rich composition, similar to the outer solar system objects. Yet this composition didn't match the high reflectivity observed at visible wavelengths, creating another layer of contradiction. The telescope's failure to detect the object directly contributed to size estimates and ruled out many exotic composition theories, but it also eliminated easy explanations for the acceleration anomaly, pushing scientists toward increasingly creative theoretical solutions. Artificial origin hypothesis. Abraham Avi Loeb, Harvard's controversial astrophysicist, dropped a bombshell that sent ripples through both scientific circles and popular media. In his 2018 paper and subsequent 2021 book Extraterrestrial, Loeb argued that Oumuamua's unique characteristics, its extreme elongated shape, unusual reflectivity and mysterious acceleration, could only be satisfactorily explained if it were an artificial object created by an alien civilization. Specifically, Loeb proposed that Oumuamua might be a light sail, which is, an ultra-thin sheet of material designed to be pushed by stellar radiation for interstellar travel. This technology, while still theoretical for humans, could explain both the object's extreme thinness, giving it that unusual aspect ratio, and its acceleration away from the sun via solar radiation pressure. The hypothesis suggested we might have witnessed discarded alien technology or even an active probe sent to investigate our solar system. Loeb's argument wasn't based on wild speculation but on systematic elimination of conventional explanations. He calculated that for solar radiation pressure to account for the observed acceleration, Oumuamua would need to be incredibly thin, perhaps only millimeters thick, which could occur naturally only under the most extraordinary circumstances. The artificial origin hypothesis sparked fierce debate, with most astronomers maintaining that extraordinary claims require extraordinary evidence. However, Loeb's rigorous mathematical approach forced the scientific community to seriously consider possibilities that had previously been relegated to science fiction, fundamentally changing how we approach anomalous observations. Dark Comet Theory. Enter the Dark Comet Theory, the scientific community's attempt to rescue Oumuamua from alien conspiracy theories while still explaining its impossible behavior. Alan Fitzsimmons and his colleagues proposed that Oumuamua represents a new class of object comets that have been so heavily processed by cosmic radiation and interstellar weathering that they've lost their ability to produce visible comas and tails. The theory suggests that during its millions-year journey through interstellar space, Oumuamua was bombarded by high-energy particles that altered its surface composition and internal structure. This processing could have created a carbonaceous crust that insulates the interior while still allowing subtle outgassing of invisible materials like hydrogen gas. In 2023, Jennifer Bergner and Daryl Seligman published groundbreaking research showing that cosmic ray bombardment of water ice can produce trapped molecular hydrogen that later escapes when heated by the sun. This hydrogen outgassing would be completely invisible to telescopes, but could generate enough force to explain the observed acceleration. The beauty of this theory is that it explains not just the acceleration anomaly, but also why Oumuamua appeared so different from familiar comets. The dark comet model suggests that interstellar space is filled with these ghostly, processed remnants of ancient planetary systems, objects that look dead but retain just enough activity to push themselves around when they encounter a star's heat and light. Dark Comet Classification. The dark comet classification emerged as astronomers realized that Oumuamua might not be unique, but rather the first detected member of an entirely new category of celestial objects. These dark comets are defined as objects that exhibit non-gravitational acceleration, the smoking gun of outgassing activity, without displaying any visible signs of cometary behavior like comas, tails, or dust production. The classification system divides these mysterious objects into categories based on their size and orbital characteristics. Large dark comets like Oumuamua follow hyperbolic trajectories and likely originate from interstellar space, while small dark comets remain gravitationally bound within our solar system. Recent discoveries have identified several potential dark comet candidates within our own solar system, including objects like 2003 RM and 2005 VL1, which show subtle acceleration signatures without obvious cometary activity. The classification represents a fundamental shift in how astronomers categorize solar system objects, acknowledging that the traditional asteroid-comet dichotomy is insufficient to describe the full diversity of objects in space. Dark comets challenge our understanding of planetary formation and evolution, suggesting that the boundaries between different types of celestial bodies are far more fluid than previously believed. This new classification system also has profound implications for planetary defense strategies, as dark comets might be more difficult to detect and track than traditional objects, yet their unpredictable acceleration could alter their trajectories in unexpected ways. Scientific debate. The scientific community remains locked in a fascinating intellectual battle over Oumuamua's true nature. With competing theories each addressing some aspects of the mystery, while leaving others unexplained. The mainstream scientific consensus, established by July 2019, favors natural explanations, with the hydrogen outgassing model gaining significant support following Bergner and Seligman's 2023 research. This theory elegantly explains both the acceleration and the lack of visible outgassing through cosmic ray processing of interstellar ice. However, alternative explanations persist, including nitrogen ice composition models proposed by Alan Jackson and Stephen Desch, which suggest Oumuamua might be a fragment of a Pluto-like exoplanet. The artificial origin hypothesis championed by Avi Loeb continues to attract attention despite mainstream rejection, particularly given the lack of definitive proof for any natural explanation. Some researchers propose even more exotic scenarios, including dust bunny models where Oumuamua could be an extremely low-density aggregate held together by electrostatic forces. The debate has highlighted crucial gaps in our understanding of interstellar object formation and evolution. The upcoming Vera Rubin Observatory, scheduled to begin full operations in the mid-2020s, promises to detect hundreds or thousands of similar objects, potentially providing the statistical sample needed to resolve the debate. Meanwhile, ESA's proposed Comet Interceptor mission could potentially visit another interstellar visitor if one arrives at the right time. The scientific controversy surrounding Oumuamua has already advanced our understanding of solar system formation, interstellar space conditions, and the importance of rapid response observations for transient celestial phenomena, regardless of which theory ultimately proves correct. That's the incredible story of Oumuamua, our first confirmed interstellar visitor that continues to challenge everything we thought we knew about space. From its mysterious acceleration to its impossible shape, this cosmic enigma proves that the universe still holds secrets we're only beginning to understand. What do you think Oumuamua really was? Natural phenomenon or something more extraordinary? Drop your theories in the comments below. I'd love to hear your thoughts. If you enjoyed diving into this cosmic mystery, hit that subscribe button and ring the bell icon to never miss another mind-bending episode from Simply Science. Until next time, keep looking up.
De nouvelles observations de 3 Atlas éclairent désormais ce mystérieux visiteur interstellaire, et les découvertes scientifiques remettent en question tout ce que nous pensions savoir sur les vagabonds cosmiques. Avec une trajectoire défiant les probabilités astronomiques et des comportements différents de ceux de tout objet naturel, ce visiteur ancien soulève de profondes questions sur sa véritable nature. L'humanité serait-elle témoin de quelque chose de bien plus extraordinaire qu'une simple comète? Découverte et détection initiale. Et si la découverte la plus importante de l'histoire de l'humanité avait failli nous échapper? 3 Atlas a été découvert le 1er juillet 2025 par le télescope Atlas au Chili, initialement désigné à 11PL3Z, avant que les astronomes ne réalisent qu'ils observaient un phénomène sans précédent. Il s'agit seulement du 3e objet interstellaire confirmé après Oumuamua en 2017 et Borisov en 2019, ce qui en fait un événement cosmique extraordinairement rare. L'objet était en fait entré dans notre système solaire bien plus tôt, mais son angle d'observation difficile à proximité de champs d'étoiles denses a retardé sa détection jusqu'à ce qu'il soit déjà bien au cœur du système solaire interne. Cette détection tardive a entraîné une perte de temps d'observation cruciale, similaire à ce qui s'est passé avec Oumuamua, lorsque l'humanité a manqué l'occasion de l'étudier en détail. L'équipe de découverte a rapidement identifié des schémas de mouvement inhabituels qui ne correspondaient pas aux objets typiques du système solaire, ce qui a immédiatement déclenché des observations complémentaires depuis des télescopes du monde entier. En 24 heures, la NASA a confirmé son statut interstellaire, la désignant officiellement comme C 2025 N1 et lui attribuant la désignation historique, 3I. Ce processus de confirmation rapide a démontré l'ampleur des progrès réalisés en matière de détection astronomique depuis la découverte controversée d'Oumuamua 8 ans plus tôt. Caractéristiques orbitales extraordinaires. Comment la trajectoire d'un objet dans l'espace peut-elle défier les lois mêmes des probabilités? 3 Atlas suit une orbite hyperbolique avec une excentricité extrême de 6,14, la plus élevée enregistrée parmi tous les objets interstellaires connus, dépassant de loin les 1,2 de Oumuamua et les 3,6 de Borisov. Cette trajectoire incroyable lui permet de traverser notre système solaire à une vitesse de 58 km par seconde, ce qui en fait le visiteur interstellaire le plus rapide jamais enregistré. Plus remarquable encore, sa trajectoire se situe presque parfaitement dans le plan de l'écliptique, les astronomes estimant que la probabilité que cela se produise par hasard n'est que de 0,2%. L'alignement écliptique signifie que l'objet se déplace le long du même plan que celui où orbitent toutes les planètes, offrant des opportunités d'observation optimales pour l'étude de plusieurs mondes lors d'un seul passage. Cette trajectoire semble délibérément conçue pour une reconnaissance planétaire complète plutôt que la trajectoire aléatoire attendue d'un objet éjecté naturellement. La mécanique orbitale suggère que l'objet a conservé cet alignement précis tout au long de son voyage potentiellement de plusieurs millions d'années dans l'espace interstellaire. Une telle précision mathématique de la trajectoire soulève des questions fondamentales. Les interactions gravitationnelles naturelles pourraient-elles produire une trajectoire aussi improbable ? La combinaison d'une vitesse extrême, d'un alignement écliptique parfait et d'une excentricité record crée une anomalie statistique qui remet en question la compréhension conventionnelle du comportement des objets interstellaires. Rencontre planétaire suspecte. Quelles sont les chances qu'un astéroïde quelconque visite précisément les planètes les plus intéressantes pour une intelligence extraterrestre ? Lors de son passage dans notre système solaire, 3i Atlas s'approche inhabituellement près de Vénus, Mars et Jupiter, les astronomes estimant la probabilité de telles rencontres planétaires précises à seulement 0,005%. L'objet passe à 0,65 unités astronomiques de Vénus, 0,19 A de Mars et 0,36 A de Jupiter, des distances qui permettraient une étude détaillée de la composition atmosphérique, des champs magnétiques et de l'habitabilité potentielle de chaque planète. Plus intriguant encore, son approche au plus près du Soleil se produit précisément au moment où la Terre se trouve du côté opposé, inaccessible à toute observation directe pendant la phase la plus critique de son passage. Les scientifiques estiment à seulement 7% la probabilité que cette éclipse solaire se produise naturellement. La trajectoire ressemble à une mission de reconnaissance soigneusement planifiée, conçue pour recueillir un maximum d'informations sur notre système solaire tout en minimisant les risques de détection. Chaque rencontre planétaire se produit à des distances optimales pour que des capteurs avancés puissent collecter des données détaillées sans déclencher de perturbations gravitationnelles évidentes susceptibles de révéler la présence de systèmes de propulsion artificielle. Le schéma de visite suggère une intelligence plutôt qu'une errance cosmique aléatoire, suivant des protocoles que d'hypothétiques explorateurs extraterrestres pourraient utiliser pour étudier des systèmes stellaires potentiellement habités. Cette approche systématique des relevés planétaires soulève de profondes questions quant à la véritable fonction de l'objet dans notre environnement cosmique. Propriétés physiques et anomalies. Comment quelque chose peut-il être à la fois incroyablement ancien et parfaitement préservé pour l'étude scientifique ? De récentes observations de l'Observatoire Veras et Rubin révèlent que 3i Atlas mesure environ 1 à 12 km de diamètre, ce qui le rend nettement plus grand que les précédents visiteurs interstellaires et potentiellement le plus grand objet de ce type jamais observé. Les estimations d'âge suggèrent que ce vagabond cosmique a plus de 7 milliards d'années, antérieur à l'ensemble de notre système solaire et préservant peut-être des matériaux de l'univers primitif, une époque où la formation des galaxies était fondamentalement différente. Malgré son âge extrême, 3i Atlas semble remarquablement bien préservé, ne présentant aucune des dégradations attendues suite à des milliards d'années de bombardements de rayons cosmiques et d'impacts de micrométéorites. L'objet présente la magnitude absolue la plus brillante de tous les visiteurs interstellaires confirmés, ce qui le rend inhabituellement réfléchissant ou illuminé de l'intérieur par rapport aux débris spatiaux classiques. Sa période de rotation de 29 heures, avec une variation de luminosité minimale, suggère soit une symétrie sphérique parfaite, soit une vitesse de rotation artificiellement stabilisée, contrastant fortement avec le mouvement de rotation chaotique attendu des objets éjectés naturellement. La surface apparaît inhabituellement lisse et uniforme, dépourvue des irrégularités caractéristiques des noyaux d'astéroïdes ou de comètes façonnés par d'innombrables impacts lors de voyages interstellaires. Ces propriétés physiques créent un profil plus proche de la technologie manufacturée que de la formation naturelle, ce qui rend difficile pour les scientifiques d'expliquer comment des matériaux anciens ont pu rester aussi intacts après des éons d'exposition cosmique. Caractéristiques de type comète vs. Comportement anormal. Pourquoi cette supposée comète se comporte-t-elle différemment de toutes les autres comètes de l'histoire astronomique ? 3i Atlas présente une faible coma et une courte queue mesurant 3 secondes d'arc, confirmant un dégazage actif typique des comètes s'approchant du Soleil. Pourtant, ces caractéristiques semblent bien plus atténuées que prévu pour un objet de cette taille et de sa proximité solaire. La coma apparaît compacte et dense, contrairement à l'aspect diffus et flou caractéristique des comètes normales, suggérant une composition inhabituelle ou un confinement artificiel des matériaux expulsés. Plus intriguant encore, l'objet est dépourvu de la queue proéminente qui devrait se développer à l'approche du périhélie, avec une éjection de poussière minimale malgré un réchauffement solaire important. L'analyse spectroscopique révèle des signatures de glace d'eau, mais les schémas ne correspondent pas aux modèles attendus, les signaux observés augmentant là où les prédictions théoriques indiquent qu'ils devraient diminuer. Le dégazage semble contrôlé et limité, comme si des systèmes internes régulaient la libération de matière plutôt que de laisser les processus naturels de sublimation se dérouler sans contrôle. Contrairement aux comètes classiques, qui deviennent de plus en plus actives et chaotiques à mesure qu'elles se rapprochent du Soleil, 3i Atla conserve un comportement et une apparence remarquablement stables. Sa coloration rougeâtre ressemble davantage à celle des objets de la ceinture d'astéroïdes externe qu'à de la glace interstellaire intacte, suggérant un traitement de surface complexe ou l'utilisation de matériaux de revêtement artificiels. Ces caractéristiques contradictoires créent un profil hybride qui ne correspond ni aux classifications des comètes ni à celles des astéroïdes, exigeant de nouveaux cadres explicatifs pour comprendre les visiteurs interstellaires. Débat scientifique, naturel contre artificiel. Comment les scientifiques concilient-ils des preuves extraordinaires et la charge de la preuve extraordinaire ? Le professeur Avi Loeb, de l'université Harvard, a publiquement suggéré que 3i Atla pourrait être une technologie artificielle, soulignant sa trajectoire statistiquement improbable, sa synchronisation parfaite et ses propriétés physiques anormales comme autant de preuves justifiant une réflexion sérieuse sur les origines extraterrestres. Loeb soutient qu'écarter des possibilités artificielles sans investigation approfondie viole la méthodologie scientifique, en particulier lorsque les explications naturelles ne tiennent pas compte des caractéristiques observées. Cependant, de nombreux scientifiques reconnus rejettent ces affirmations, les qualifiant de spéculations irresponsables qui sapent la confiance du public dans la recherche astronomique et détournent l'attention des études scientifiques légitimes. Chris Lintott, de l'université d'Oxford, a qualifié l'hypothèse extraterrestre d'« absurde », soulignant que les affirmations extraordinaires nécessitent des preuves extraordinaires qui n'existent tout simplement pas. Le débat porte sur des questions fondamentales de méthodologie scientifique. Les chercheurs doivent-ils explorer toutes les explications possibles, même celles qui semblent farfelues, ou conserver des approches conservatrices privilégiant les interprétations conventionnelles ? Les critiques affirment qu'envisager des explications extraterrestres sans preuve définitive encourage les théories du complot et porte atteinte à la crédibilité scientifique. Les partisans de cette théorie rétorquent que la science progresse en remettant en question les hypothèses et en étudiant les anomalies qui ne cadrent pas avec les modèles établis. Cette controverse reflète des tensions plus larges au sein de l'astronomie quant à la manière de concilier une recherche ouverte et un scepticisme rigoureux face à des découvertes potentiellement révolutionnaires. La communauté scientifique reste divisée sur la question de savoir si 3i Atla mérite une analyse conventionnelle ou s'il s'agit d'un phénomène nécessitant des approches d'investigation entièrement nouvelles. Les mystères de l'analyse spectrale. Quels secrets se cachent dans les signatures lumineuses qui remettent en question notre compréhension de la chimie interstellaire ? Des observations spectroscopiques réalisées avec le télescope Gemini S et l'IRTF de la NASA révèlent que 3i Atla contient de la glace d'eau en abondance, mais les schémas spectraux présentent des caractéristiques déroutantes qui ne correspondent pas au modèle théorique de composition naturelle des comètes. Le spectre optique présente un rougissement d'environ 10% pour 1000 angstroms, ressemblant davantage à celui des astéroïdes de type D qu'à celui des comètes classiques riches en glace, suggérant des conditions de formation inhabituelles ou des traitements de surface artificiels. L'analyse dans le proche infrarouge s'aplatit à 3% pour 1000 angstroms, indiquant la présence de gros grains de glace d'eau. Pourtant, la bande d'eau attendue de 1,5 micron reste mystérieusement absente malgré des signaux puissants à d'autres longueurs d'onde. Les scientifiques ont réussi à modéliser le spectre en utilisant 70% de météorites du lac Tagish combiné à 30% de glace d'eau, mais cette composition semble incompatible avec celle des objets formés dans des systèmes stellaires lointains il y a des milliards d'années. La stabilité spectrale sur 9 jours d'observation suggère des propriétés de surface remarquablement uniformes, contrastant avec les comètes typiques, dont la composition varie selon les régions exposées au réchauffement solaire. Les mesures de couleur à travers divers filtres confirment des caractéristiques rougeâtres persistantes, révélatrices de matériaux organiques complexes, préservant potentiellement les signatures chimiques des environnements de formation d'étoiles extraterrestres. Cependant, les rapports isotopiques et les abondances élémentaires semblent étonnamment similaires à ceux des matériaux du système solaire, ce qui soulève des questions. S'agit-il réellement de matière interstellaire intacte ou d'un phénomène plus familier ? Ces énigmes spectroscopiques exigent de nouveaux cadres théoriques pour comprendre comment les objets interstellaires préservent et modifient leur composition originelle au cours de leurs millions d'années de voyage à travers la galaxie. Conséquence de l'hypothèse de la forêt sombre. 3 Atlas pourrait-il représenter la première rencontre de l'humanité avec la terrifiante théorie des jeux cosmiques connue sous le nom de forêt sombre? Cette hypothèse suggère que les civilisations intelligentes à travers l'univers restent cachées et silencieuses, appliquant des protocoles de furtivité stricts pour éviter d'être détectées par des espèces potentiellement hostiles susceptibles d'éliminer leurs concurrents avant qu'ils ne deviennent une menace. 3 Atlas présente un comportement furtif parfaitement cohérent avec les missions de reconnaissance conçues pour étudier les systèmes planétaires, tout en minimisant les risques de détection et l'exposition aux réactions défensives. La trajectoire de l'objet permet des relevés complets du système solaire tout en restant caché derrière le Soleil lors de son approche la plus vulnérable, au moment où tout système artificiel serait le plus facilement détectable. Son timing précis garantit des possibilités d'observation minimales pendant les pics d'activité, conformément au protocole que les civilisations avancées pourraient utiliser pour explorer prudemment des systèmes habités potentiellement dangereux. La théorie de la forêt sombre prédit que des visiteurs extraterrestres mèneraient des missions de reconnaissance rapides et efficaces pour évaluer le niveau de menace et la disponibilité des ressources avant de décider d'établir le contact, d'éliminer la concurrence ou simplement d'éviter toute détection. Le comportement de 3 Atlas correspond aux prédictions théoriques sur la manière dont les espèces intelligentes pourraient approcher des systèmes stellaires inconnus, recueillir un maximum d'informations tout en conservant des voies de fuite et en évitant la confrontation. L'ancienneté de l'objet suggère qu'il pourrait représenter la technologie de civilisation ayant réalisé des voyages interstellaires il y a des milliards d'années, lorsque la galaxie était plus jeune et potentiellement plus propice à la vie. Si cette interprétation s'avère exacte, l'humanité pourrait vivre son premier contact avec une intelligence extraterrestre. Mais ce contact est conçu pour rester indétectable jusqu'à ce que les visiteurs puissent déterminer si nous sommes des amis, des ennemis ou des primitifs sans rapport. Contexte historique et leçons. L'arrivée de 3 Atlas nous apporte des informations cruciales, acquises lors de nos précédentes rencontres avec des vagabonds interstellaires, et nous révèle les opportunités manquées. Lorsqu'un Oumuamua a été repéré pour la première fois en 2017, la communauté astronomique n'était absolument pas préparée à étudier un phénomène aussi extraordinaire. Robert Werik, qui a fait cette découverte grâce au télescope Pan-STAR 1 à Hawaï, a reconnu que le départ rapide de l'objet avait laissé de nombreuses questions fondamentales sans réponse. L'accélération énigmatique affichée par Oumuamua sans aucune activité cométaire visible continue de dérouter les scientifiques aujourd'hui, démontrant l'importance cruciale de protocoles d'observation immédiats et complets. 2 ans plus tard, Gennady Borisov a découvert 2 Borisov depuis son observatoire privé en Crimée, offrant aux astronomes une précieuse seconde opportunité, mieux gérée mais néanmoins limitée par des contraintes technologiques. Mark Norris, de l'Université du Lancashire central, a souligné que 3 Atlas représente notre plus grande opportunité à ce jour de mener des études approfondies d'un visiteur interstellaire à l'aide d'instruments de pointe et de campagnes d'observation coordonnées à l'échelle mondiale. Les systèmes de détection perfectionnés des relevés célestes modernes, associés à des réseaux de communication mondiaux instantanés, ont permis une collaboration en temps réel sans précédent entre les observatoires du monde entier. Ces leçons durement apprises lors de précédentes rencontres d'interstellaires ont fondamentalement transformé la façon dont la communauté scientifique aborde ces événements cosmiques exceptionnellement rares. Observations et implications futures. Les prochains mois apporteront-ils à l'humanité des réponses définitives sur la véritable nature de 3 Atlas, ou approfondiront-ils à jamais le mystère? Le périhélie du 30 octobre 2025 offre aux scientifiques la meilleure occasion de mener une analyse approfondie avant que l'objet n'entame son départ définitif de notre système solaire. De nombreux télescopes du monde entier coordonnent des campagnes d'observation sans précédent utilisant toutes les techniques disponibles, de la radioastronomie à la détection des ondes gravitationnelles, garantissant qu'aucune preuve potentielle n'échappe à l'analyse. L'objet réapparaîtra de derrière le Soleil en décembre 2025, offrant une dernière fenêtre d'observation pour confirmer ou infirmer les théories d'origine artificielle avant sa disparition définitive dans l'espace interstellaire. Des missions spatiales avancées, telles que MAVEN, Mars Reconnaissance Orbitée et Jupiter Icy Moons Explorer, tenteront des observations à courte portée lors de rencontres planétaires, révélant potentiellement des détails de surface impossibles à détecter depuis la Terre. Les scientifiques développent de nouvelles techniques d'analyse spécifiquement conçues pour distinguer les objets naturels des objets artificiels, créant ainsi des cadres qui guideront l'évaluation des futurs visiteurs interstellaires. La collecte exhaustive de données de 3 Atlas pourrait révolutionner la compréhension des populations d'objets interstellaires, de leurs mécanismes de formation et de la prévalence potentielle de technologies extraterrestres dans notre voisinage galactique. Ces observations prouveront soit définitivement que 3i Atla est une comète naturelle, mettant fin aux spéculations sur son origine artificielle, soit apporteront des preuves qui modifieront fondamentalement la compréhension que l'humanité a de sa place dans l'univers. Les implications dépassent largement l'astronomie et pourraient affecter les stratégies de défense planétaire, la coopération spatiale internationale et la préparation à long terme de l'humanité au contact avec une intelligence extraterrestre. Les futurs systèmes de détection sont conçus pour identifier des objets similaires beaucoup plus tôt, ce qui permettra des années plutôt que des mois pour une étude détaillée et une interaction potentielle. Alors que 3i Atla poursuit son énigmatique voyage à travers notre système solaire, les scientifiques se lancent dans une course contre la montre pour percer ses secrets avant qu'ils ne disparaissent à jamais. Que ce visiteur ancien soit une relique naturelle venue d'étoiles lointaines ou quelque chose de bien plus extraordinaire, sa découverte marque un tournant dans la conscience cosmique de l'humanité. La vérité sur 3i Atla pourrait remodeler notre compréhension de la vie, de l'intelligence et de notre place dans l'univers. Restez curieux du cosmos avec Science Simple, aimez, partagez et abonnez-vous pour recevoir les dernières découvertes aux confins de la connaissance humaine.